This is Miss Humbert here. Today we're going to be doing Unit 1 Notes 1, so your very first notes video of the year. So in Unit 1 Notes 1, we're just going to do a review of stuff that you did in 8th grade. So this is a review of solving equations, just making sure you remember your order operations and all of the stuff that is kind of applied in that realm. So let's go ahead and let's take a look at that. So first of all, how do I solve equations with multiple steps? So I want you guys to actually write this step down. So that way, if you get stuck on a problem, you're like, I don't know what to do next, look at your steps. Have you completed step 1? Have you completed step 2? And so forth. So the first step is simplify each side of the equation by of the equal sign by distributing and combining like terms. So like terms are things that can be added together. Like 3x and 2x, those are like terms. 4 and 3, those are like terms. So you want to just simplify each side of that equal sign. The next one would be to gather variables to one side of the equal sign. So if I have x's on both sides, I need to pick a side and I need to do the opposite operation to get that other x over to the other side. The next thing we're going to do is use addition or subtraction to cancel out the constant. Now I can talk a lot faster than you can write, so feel free to pause the video if you need to. So when I talk about the constant, I'm talking about the thing that's just a number. So I need to add or subtract it so that it can get over to the other side because I'm trying to isolate that x or that letter completely by itself. And last but not least, we're going to use multiplication or division to cancel the coefficient. So the coefficient is that number that's multiplied or divided right outside of that letter. So we need to do the opposite to get rid of that. So let's just take a look at this first problem here. So the first thing I want to do is, well, step 1, simplify each side of the equation sign by distributing. Well, I don't have any distributing I have to do here. So then my next step is to combine like terms. So I have x plus 5x. So I'm going to take x plus 5x, and that's going to give me 6x. And then I still have this minus 5, and then I have is equal to 1. So now what I'm going to do is add 5 to both sides. So once I do that, that'll cancel out the 5's on this side. So then I have 6x is equal to 1 plus 5, which is 6. So now I'm on to step 4. I need to use multiplication or division to cancel the coefficient. So what I'm going to do is divide both sides by 6. So when I divide both sides by 6, I end up getting that x is equal to 1. So that is my final answer for number 1. Now let's take a look at number 2. For number 2, there's no distributing that I have to do. What I need to do is get the x's on the same side. I always like to stick with positives. So what I'm going to do is I'm going to take this negative 2x and I'm going to get it over to the other side. So since it's a negative 2, in order to get it over to the other side, I need to add 2x. So 6x plus 2x is 8x. And then the rest of the equation is going to stay exactly as is. So now what I need to do is, since it's a minus 11, I need to add 11 to both sides. So then I get 8x is equal to 5 plus 11, which is going to give me 16. Now I need to get rid of that coefficient that's out in front of the x. So I notice that the 8 is being multiplied by the x. So in order to get it over to the other side, I'm going to divide both sides by 8. Once I do that, I end up getting 2. So my answer for number 2 is x is equal to 2. Now, let's take a look at number 3. So in order to simplify number 3, I need to start with step number 1, and I need to distribute. So in order to distribute, I'm going to take this negative 4, and I need to multiply it to each thing that's inside of the parentheses. So negative 4 times x is negative 4x. Negative 4 times negative 3. When you multiply two negatives, it's always going to become a positive. So then you get plus 12. And that's going to be equal to negative x. Now I want to play this smart. I want to get my x's to the same side. So I have this negative 4x and this minus x. And so what I'm going to do is I'm going to bring this 4x over to the other side, because that way my x's are isolated on one side. So here I'm going to have 3x, and that's going to be equal to 12. You could have done it the other way. It still would have worked out with the same answer. You do have a lot of choice in here. So that 3 is being multiplied by the x. So in order to get rid of it, I need to divide both sides by 3. Well, 12 divided by 3 is going to give me 4. So my answer then is x is equal to 4. So let's take a look at number 4. So for number 4, I noticed that I have this 1/2 x here. I don't really like fractions that much, so I'm going to do the best I can to get rid of them. So when there's no coefficient, that's the same as there just being a 1. So really what I have is 1/2 x plus 1x. So I have negative 10 here, and that's going to be equal to 1/2 x. Now, instead of writing it as 1x, I want to make it so that it has a common denominator with this guy right here. So I want the bottom to be 2. Well, if I write it as 2 over 2, 2 over 2 is really the same thing as 1. But now, since I have the same number on the bottom, I should be able to add the 2 together. So when I add fractions, I'm going to add the numerators. So that's going to give me 3, and then I'm going to keep that 2 on the bottom, and then I'm just left with x. So now, in order to get rid of this fraction, first thing I'm going to do is I've noticed that it's being divided by 2. So I'm going to start by multiplying both sides by 2. When I do that, I get a negative 20 is equal to 3x. Those 2's are going to cancel each other out. The last thing I need to do is divide both sides by 3, and then I get that x is equal to a negative 20/3. And you can leave that as a fraction. If you want to write out the decimal, that's fine, but you do need to make sure that you are rounding correctly. So let's take a look and let's talk a little bit about proportions. So what are proportions? Okay, proportions are two ratios that are equal to each other. Now, ratios are fractions. So if I have A over B, that's a ratio. Okay, it's kind of a fancy word of saying a fraction because we're setting things up in proportion with each other. How do we solve a proportion? So we're going to cross multiply. What does cross multiply mean? Cross multiply means you're going to do the top on one side times the bottom of the other, and the top on the other side to the bottom of the other, and you're going to set them equal to each other. Okay? Then you're going to solve the remaining equation. So you're going to use all the steps that we talked about in those first 4 problems once you do the cross multiplication itself. So let's go ahead and let's practice that. Let's do a little bit of cross multiplication. So first thing I'm going to do is multiply this times this, and this times this. Now I want you to note that this only works if we have 2 fractions set equal each other. Okay, so then 2 times x is 2x, and 15 times 8 is going to give me 120, or 126 apparently, 120. So then, in order to solve for x, all I have to do is divide both sides by 2. And then I end up getting x is equal to 60. So I know sometimes our brains tend to freeze when we see that fraction, but here it's actually not that bad. So let's go ahead and let's take a look at number 6. So for number 6, what we're going to do is, again, cross multiply here and here. It's okay that there's a decimal. They will not kill us. I promise you that. So we're going to take 3.27 and multiply that times x, which is just 3.27x. It doesn't matter what side you put it on. 6 times 11 is going to give me 66. So now what I'm going to do is I'm going to take that 3.27x and I'm going to divide it by 3.27. Again, trying to get rid of that so I can get my x all by itself. Now when I do that, I get x is equal to 20.18. Now I always encourage students to try the calculations in their calculator along with me so that they make sure they're doing it correctly. Also, so that they make sure they're rounding their answer correctly. You can't just cut off a number and say, "Oop, I'm done." You need to be making sure you check that next number to make sure you've rounded correctly. Now, let me take a look at number 7. So for number 7, we're going to cross multiply. So 3 times x is going to give me 3x. And then we're going to have 2 times x minus 2. So what I want you to notice is that I actually put those little parentheses in there. That's because I need to distribute and make sure that 2 is multiplied by both parts of that x minus 2. So when I do that, I get 2x minus 4. So the next thing I need to do is take that 2x and I'm going to subtract it over to the other side. So 3x minus 2x is just x, and these have already canceled out. And then I get negative 4. So from all that crazy fraction business, we ended up getting that x is equal to negative 4. Not too shabby. So let's take a look at this word problem. When I do word problems, I always like to underline numbers or words or anything that's going to help me solve the problem, anything that I think is going to be important to me later on. So your school is building a new computer lab. 400 square feet of the center will be available for computer stations. So I'm going to underline stations because I think we're going to be working with that. Each station requires 20 square feet. Write and solve an equation on how to find how many computer stations can be placed in the new computer lab. So first thing I need to do is pick a variable. Well, I'm going to say x. Well, what's x going to represent? Well, it's going to represent the number of stations that we can have. Okay? So for every x station we have, it's going to take up 20 feet of space. Now that's going to be equal to the 400 that we have reserved in the center of the room. So now what I'm going to do is I'm going to divide both sides by 20. And when I do that, I end up getting 20. Now, this is a word problem. I can't just say the answer is 20. I have to explain what 20 means. And we talked about x equaling stations. So that means that we can fit 20 stations into that center computer lab area. Word problems can be tricky. So what I like to do is I like to lay out some key words. And if you see that word in a word problem, you're like, oh, that means addition. Oh, that means subtraction. So first of all, when you see the words added to, increased by, more than, some, addition to, you're going to use a plus sign. Hopefully you can draw it better than I can. Subtracted from, decreased by, less than, difference. That's a huge one. You're going to see difference a lot. So maybe going to underline that. Difference, that's an important one. Taken away from. All of that means subtraction. Now with subtraction, you need to make sure you're paying attention to the order that the problem tells you it in, because the order matters here. So then, multiplied by, product, 1/3 of, 1/2 of, times, all of those things imply multiplication. And there's multiple ways that we do that. We use the star, and sometimes we use a dot, and every once in the very, very rare time you will see an x. I don't like to use the x because I use x so often as a variable. Okay, so let's take a look at this next one. We have quotient divided by, split into groups and pieces. So we're going to do divided by, like that. So we have the divided by symbol, and we also can use the fraction bar. The fraction bar also implies divided by as well. And then if we have squared, that means we're going to take a number, let's call it a, and we're going to raise it to the second number, second power. So when we say something is squared, what we're really doing is taking a times a, and we note it as a to the second power. Let's go ahead and take a look at cubed. So when we're cubing something, we're going to take a to the third power. So what cubed means is we're really doing a times a times a. So then if we have something to the nth power, we're going to take our letter, say a, and we're going to raise it to the nth power. So what that means is we're taking a and we're multiplying it n times, whatever that number n is. The last thing is the same as or is equal to, we're going to use the equal sign. Okay, so that represents equaling something in a word problem. So let's just do some practice with putting these numbers into practice. So the sum of a number and 16 is 32. So whenever it says a number on here, I'm going to use x as my number. That's typically my variable of choice, and that's what you see most often. So the sum of a number, we're going to call it x, and 16, okay, I need to add 16, is going to be equal to 32. The product of 16 and a number, so 16 times a number is equal to 32. Now, a lot of times when a variable is involved, you're not necessarily going to see the times sign. This can also be written this way, as 16x is equal to 32. So let's take a look at number 11. The quotient of a number and 16 is 32. So we're going to have x be that number, and then we're going to divide it by 16, and that needs to equal 32. We're not going to solve any of these. We're just working on setting them up. The fourth power of a number is 16. So we don't know what that number is, but we're going to raise it to the fourth power, and that's going to be equal to. It's really important that you guys recognize that is means equals. That's going to go a long way for you. The difference of a number and 16 is 32. So that number, remember that difference means subtraction. So that minus 16 is going to be equal to 32. So let's take a look at that last word problem. A rock climbing gym charges non-members $16 per day to use the gym and $8 per day for equipment rental. Members pay a yearly fee of $455, so they're only going to pay that one time for unlimited climbing and $6 per day per equipment. Write and solve an equation to represent how many times you must use the gym to justify becoming a member. So here's what we're going to do. We're going to set up one side, and that's just going to be the cost for a non-member. And then we're going to set that equal to the other side, which is going to be the cost for a member. So let's just start by setting up that equation. So it's going to cost a non-member. So we're going to let X represent the number of days that you actually go to the gym, because we're trying to figure out how many times or how many days you can go to the gym before you need to get a membership. Okay? So we have, for every X day we go, we have 16 just to get in. And then for every X day we go, we need $8 for that equipment rental. Then, if we're a member, we come in and we say, okay, I'm just going to pay $450. So when I pay that, I don't have to pay this $16 per day entry fee. And also by being a member for the equipment rental, for every X day I go, I only have to pay that $6 equipment rental. So now we're going to go ahead and solve this equation. So I'm just going to write it out down here. So first thing I want to do is simplify my like terms on the left-hand side. So 16x plus 8x is going to give me 24x. And then I get 6x minus 450. So now I need to figure out how to get my x's on the same side. I highly suggest getting the 6x over to the same x as the 24x. So we have minus 6x minus 6x. So 24 minus 6x is going to give me 18x. And that's going to be equal to 450. Now that 18 is being multiplied, so I'm going to go ahead and divide both sides by 18. Now, when I do that, 450 divided by 18 is going to give me 25, and then I'm just going to write days. Okay, so that concludes your note video for today. Let me know if you have any questions or you need help. Thanks for listening.